Okay, so let's see if we can't get this right. So notice they're asking for g of f of negative 1. So how do you do this? The most efficient way, anyways, is let's do f of negative 1. And whatever that answer is, we put inside of g. So what is f of negative 1? Well, f of negative 1 would be this. Notice how I put negative 1 right in there for x. So I get negative 5 minus 8, which is negative 13. Now we're going to plug this inside of g. So g of negative 13 is what you officially would call it. Because remember, this is the f of negative 1, right? So we're doing g of f of negative 1 is 7 minus 2 times negative 13 squared. So we have 7 minus 2 times. Now, negative 13 squared is 169. And now it's just a matter of doing the math. Hopefully my mental math is correct. So 7 minus, if I times by 2, that's 320 plus 18, 338. So hopefully I'm not making a mental mistake here, but that's negative 331 unless I made some mental math. The setup was perfect though. So quick replay, to do g of f of negative 1, you're going to do f of negative 1 first. Then you're going to take that answer and plug it inside of g. Okay. Now, number 4 says the graph of absolute value parent function is shifted 3 units right and 5 units down, then vertically stretched by a factor of 2. Write the equation of the transform function. So basically, we're going to take y equals absolute value of x, right? And if we're going to shift it 3 right, we have to remember that's minus 5. So now we have the absolute value of x minus 5. A minus actually shifts it right. A plus shifts it left. Remember, it's backwards. Now, what about 5 down? We would do a minus 5. That would bring it 5 down. To stretch it by 2, we will times by 2, and it's done. Okay. On number 5, we have a piecewise function here. Now notice when x is less than 2, it's a squared function. So what I recommend you do is make a little table. And we're going to plug in 2 even though it's not included, because we want to see where it would be if 2 was part of its domain. And then we want numbers less than 2. So I would definitely do 1 and 0. And let's see where it comes out. So if I plug in 2, I get 2 because 2 squared 4 minus 2 is 2. If I plug in 1, 1 minus 2 is negative 1. If I plug in 0, I get negative 2. Now let's do one more just to make sure. Because 0, negative 2 is the vertex. So if I plug in negative 1, I still get negative 1 as well. So now that I have that basically set up, let's go ahead and graph that. So 2, 2 is right here. Now I'm going to do an open circle, right? Because it's not going to actually get to 2. It's not part of its domain. 1, negative 1 is right there. 0, negative 2 is right there. And negative 1 is there. So as you can see, here's our parabola coming up like so. But there's going to be that open circle at 2, 2. Now we got to do the second half of our function, which is the absolute value. Let's make a little table here. We definitely want to put in 2 because that's basically its starting point. And then let's just put in 3 and 5 and 6. Now, the reason why I did 5 is because I know 5 minus 5 is 0, and that's where the vertex is going to be. and then I want at least 1 point to the right of my vertex. So if I plug in 2, I get the absolute value of -3 plus 4. And that's just 3 plus 4, which is 7. If I plug in 3, I get -2 absolute value of plus 4. And 2 plus 4 is 6. If I plug in the 5, I get 0 plus 4, which of course is 4. That's the vertex now. If I plug in 6, I get 1 plus 4, which of course is 5. So, let's graph it and then we'll be done. 2, 7, notice, is off my screen. Let me use black here. So it's about right there. But notice I'm going to make that a solid dot because basically we have a gap in here. Okay. We have a gap in there because that's where it jumps. That's why it's called a step function. 3, 6 is about right there. About right there. 5, 4 is about right there. And 6, 5 is about right there. So you can see here is my V. Now let's put in our arrows there on each end because it goes on forever on the left and the right. But there is my graph of my step function.